Hello, pre-calculus 2-4 zeros of polynomial functions. Okay, so we are dealing with this rational zero theorems. So, rational zero theorems, when you have a polynomial like this, constant leading coefficient. So, factors of A being leading coefficient, goes to denominator. Factors of C being constant. So that is possible rational zeros. So it might be easier if I give an example. List all possible rational zeros of f of x. So let's deal with that one first. So be careful, I'm not asking you to find rational zeros. I am asking you to find all possible rational zeros. So some of them are actual zeros, some of them are not zeros. So how do we do that? Factor of constant. Okay, factors of constant. Factors of 4 is what? 1 and 4, 2 and 2. Okay. Factors of leading coefficient. Leading coefficient is highest power of x, number in front of it, which is 1. Factor of the leading coefficient is just 1. So that over this, numerator, denominator, numerator, denominator, numerator, denominator is a combination. So 1 over 1, 2 over 1, 4 over 1, all plus minus, plus minus, plus minus. So we got 6 numbers. Over 1 doesn't do much. So plus minus 1, plus minus 2, plus minus 4. We got 6 answers. That is possible rational zeros. Possible rational zeros are this. Plus minus 1, plus minus 2, plus minus 4. Now the second part of the question, then determine which, if any, are zeros. So there are 6 possibilities. Which of them is actual zero? How are we supposed to tell that? Well, we learned that from last class. What you have to do with the synthetic division with 1 versus this, remainder has to be 0. Then one is actual 0. So you might say, I don't know what you're talking about. Well, here. So we have 6 candidates. So you have to check one by one. So 3, 2, 1, 0 power. So you got 1, minus 3, minus 2, 4. You have to check 1 and hoping for 0 at the end. So synthetic division, adding, multiplying, adding, multiplying, adding, multiplying, adding. We got the 0. So 1 was actual 0. So we got 1. We got lucky. Well, we have 5 more to go. So we have to try minus 1. Okay? So for example, you can try with the minus 1. Do you remember the trick? Once you get the 0, you get to use this leftover. If you don't get the 0, you cannot use it. But once you get the 0, you get to use this for the other eligibility of a factor or not a factor. Okay? If you can start with the very original, that's okay too, but that's going to be more work. So once you get the 0, you get to use this 1 minus 2 minus 4, and you're hoping, can I do minus 1? Adding, multiplying, adding, multiplying, adding, it's not gonna work. What does that tell us? -1 is not gonna work. Can I try 2? Yes. -2? Yes. 4? Yes. -4? Yes. It's gonna take for a while. If you check every single thing, whatever gives you remain as a 0 at the end is a real 0. And they are saying if you try all that, happen to be only 1 is actual 0. Everything else is just possible real rational 0, but actual answer is only one answer, which is 1. So of course, as you saw, I only did the 2 numbers. You are supposed to do synthetic division 1, 2, 3, 4, 5, 6 of them. Okay? So you might say, well, that's a very time consuming. Is there a way actually you can do better to tell which of them are actual zeros? You can get some of it using graphing calculator. So let me share that with you. So what you can do is you can actually graph it. So y equal to x to the power of 3 minus 3x squared minus 2x plus 4. Okay, so once you graph it, wherever it hits x-axis is zeros. So as you can see, that's some decimal here. We got nice integer right here, x equal to 1. You can verify that if you go table, x equal to 1, y value has to be 0. Yeah, x equal to 1 is the real 0, which is nice integer. So if you graph it, you get to see it. So this is the method used like way back when they didn't have a calculator whatsoever. Okay. Okay, you should try. List all possible rational zeros of this, then determine if any are actual zeros. You do it. Pause it, try. Okay, if you have tried, let me show that to you. So leading coefficient here is 1. So factors of leading coefficient is actually 1. There's no other number, just 1. Okay, factors of constant is -1. Constant is -1 here. We don't have many. 1 and -1. So this case, it's not that bad. So numerator over denominator. Numerator over denominator. So you got 1 over 1, you got -1 over 1, and I was gonna do plus minus, but we already covered the plus minus already. 1 and -1. So that's the all possible rational zeros. So all possible rational zeros are, yeah, right here. Possible rational zeros are 1 and -1. And what is actual zero? So you should try synthetic division with 1, -2, busted. 1 is gone. Synthetic division with -1, we got the 0. So that's the guy. Okay, only one answer, which is -1. Okay, when you do synthetic division, be careful. Third power, second power is missing, so you have to reserve the second power spot with the 0. Just be careful with that. So real 0 is actually -1. So that's a possible zeros. And that is actual rational 0. Okay, pause the video. Please try this. Okay, if you have exactly the same question, the thing is leading coefficient is still 1. Leading coefficient, factors of leading coefficient 1 is still 1. Well, factors of constant, which is -4, has quite a bit. 1 and 4, 2, and all plus minus. Okay, 1 times 4, so you can put minus somewhere. So 1 over 1, 2 over 1, 4 over 1. Over 1 doesn't do much. 1, 2, 4, all plus minus, plus minus, plus minus. We got 6 possible rational zeros. Then what? You have to get what is actual zeros. So what do you have to do? Synthetic division with 1, synthetic division with -1, synthetic division with 2. Keep going. What are we looking for? Remainder to be 0. Excuse me. You got remainder 0. That is actual zeros. So if you try, you will end up with -1 and 4. Okay? Well, you might say, but can I check it by graphing it? Yes. If this was in-person learning, I will ask you to do that usually without graphing calculator to force you to do the synthetic division. But if you say, well, let me just check it using calculator, then you can type it in. So actually the fourth power, minus 12x squared minus 12x squared minus 15x minus 4. Fourth minus 12x to the square minus 5. Okay, so if you graph it, do we get 9? Okay, I got -1 right here, 4 right here. Okay, -1 right here, 4 right here. And you can also verify that from the table. -1, x -1 right here. Y value is 0. X 4 right here. Y value is 0. So using calculator, checking that is so simple. So right here, the actual zeros. Okay, list all possible rational zeros of this, then determine which, if any, are zeros. Exactly the same thing. Okay. Only thing is now leading coefficient is not 1 anymore, so that will give you more choices. So leading coefficient, which is a 2, factors of 2 will be 1 and 2. Now, factors of constant, which is 15, 15 as well, 1 and 15, 3 and 5. So numerator, denominator, numerator. So you have to do all possible combination. So denominator can be 1, 1 over 1, 3 over 1, 5 over 1, 15 over 1. Remember, we have other factor of leading coefficient. So you can do 1 over 2, 3 over 2, 5 over 2, 15 over 2. Okay? All plus minus. All plus minus. Plus minus, plus minus, plus minus. So we have quite a bit here. We got 8 here, another 8 here. So we got 16 possible rational zeros. Yeah. So over 1 doesn't do much. So 1, 3, 5, 15, plus minus. 1 over 2, all that plus minus. We have 16. So make sure when I ask you all possible rational zeros, I need this list. That is the answer for all possible rational zeros. Up to here is all answer for all possible rational zeros. Okay, then you say, so I have 16 numbers. How am I supposed to build zeros? So back in the day, they set down synthetic division one by one, all 16 of them. That's what we did back in the day. Okay, I probably not gonna ask you to do that. That's a waste of time. So you can just graph it. So let's go to equation 2x to the third power. So the 2x to the third power, 2x to the third power minus 5x squared minus 28x plus 15. Graph it. Okay, I got nice integer right here, minus 3 and 5. And this is a decimal, so that's not that useful here. So I got minus 3 and 5 values. Okay, that's pretty important information. Minus 3 and 5. So I got minus 3 and 5. Okay. So minus 3 and 5, we got 2 of them, minus 3 and 5. And you might say, well, how am I supposed to get 1/2? Well, so from there, you have to plug it in as a synthetic division. Plug it in as a synthetic division. You keep trying, keep trying, keep trying. Then when you do plug it in 1/2 synthetic division, it will work. So you will get 0 at the end. Okay. There's a way you do manually that's coming up from next lesson. Okay, pause the video, please. Try this. So if you do all that combination, you're supposed to get all those. Then actual 0, if you graph it using graphing calculator, you'll get 5 as the answer. So in case you didn't quite catch this here, leading coefficient here is a 4. Factors of 4 is 1, 2, and 4. We have a 3 now. Okay, let's look at the factors of minus 5, which is 1 and 5. We will have to deal with a minus. Okay, so 1 over 1, 5 over 1, 1 over 2, 5 over 2, 1 over 4, 5 over 4. And all plus minus, plus minus, plus minus, plus minus, plus minus, plus. So we got 1, 2, 3, 4, 5, 6. 6 times 2. We got 12 answers for all possible zeros. So if I were you, I'll probably graph it, find the 0, actual 0, which will be 5. Okay?